All right, everyone, let's dive into a topic that honestly separates the pros from the rookies. We're talking about mastering variability. Because look, it's not just about hitting your average target. It's really all about consistency and predictability. So, let's kick off with a classic scenario, something you'll definitely run into. Imagine you're sourcing a critical part, right? You've got two suppliers, and on paper, their average performance is exactly the same. So, are they equally reliable? Your first instinct might be to say, yeah, sure, but is that really the whole story? Let's find out.
And boom, this chart right here, this is the whole ball game. It shows you exactly why the average can lie. Look at the supplier on the left. See how all those bars are huddled together? That's a tight, predictable, stable process. You know what you're getting. Now look at the other supplier. Same average, sure, but their performance is all over the map. In our line of work, that kind of inconsistency, well, that's just a recipe for disaster. That's risk.
Okay, so this brings us to a really crucial point. If we're serious about managing our systems, we've got to look beyond the average. We have to measure the spread.
So what is variability, or dispersion? Simply put, it's a measure of how spread out your data is. Are all your data points best friends, huddled together in a tight group, or are they scattered to the four winds? Low variability is good. It means things are stable. High variability? Well, that usually means something's wrong and you need to investigate. Now, the simplest way to measure this spread is something called the range. Super easy, right? You just take the biggest number and subtract the smallest number. Done. It's quick, it's dirty, but it has a huge flaw. For example, with this nice clean data set here, 7 through 12, the range is just 12 minus 7, which gives us 5. And you know, that seems pretty reasonable. It looks like it works. But what happens when we throw a wrench in the works? Let's add a single outlier. And trust me, this happens all the time. A sensor goes haywire, someone types a number wrong, whatever. Now watch what this one goofy data point does to our simple little measurement.
Whoa, look at that. The new range is 119. It just exploded. We went from 5 to 119 because of one bad number. This gives us a totally misleading picture of how consistent our data actually is. So bottom line, the range is fragile. It's just too easily fooled by outliers.
Clearly, we need a better tool, something more robust, something that looks at every single data point, not just the two extremes. And that's where variance and standard deviation come in. Okay, before we even touch the scary-looking formula, let's just think about the logic here. It's actually a pretty simple idea in 4 steps. First, you find the middle of your data, the average. Easy. Second, for every single data point, you figure out how far away it is from that average. Third, and this is clever, you square all those distances. Why? Well, it gets rid of any negative numbers, and it makes the faraway points count for more. Finally, you just find the average of all those squared distances. That's it. That's variance. Okay, here's the formula you'll see in textbooks. This is for sample variance. And let's be real, we're almost always working with a sample, not the whole population. Now, there's one little detail here I want you to notice. We divide by n minus 1, not just n. It's a little statistical trick called Bessel's correction. All you really need to know is that using n minus 1 gives us a slightly better, more honest estimate of the real spread when we're only looking at a piece of the puzzle.
All right, enough theory. Let's roll up our sleeves and actually calculate this stuff. We're going to walk through a super common scenario where your data is already grouped into bins.
So here's our starting point. We've got a bunch of sugar bags, and they've been sorted by weight into these different groups, or classes. The second column, F for frequency, just tells us how many bags are in each group. Our mission, should we choose to accept it, is to find the standard deviation for all of this. First things first, we can't really do math with a range like 20 to 40 kilograms. We need one number to represent that whole group. The easiest way to do that? Just find the midpoint. We'll call that X. So for that first group, 20 to 40, the midpoint is, you guessed it, 30. And we just do that for every single row. Okay, step 2. We're going to add a new column called F times X, or Fx. It's exactly what it sounds like. You just multiply the frequency from the second column by the midpoint from the third column. This column is super important because it's helping us build towards finding the overall average weight of all the bags combined. And for our final column, we need F times X squared. Now, the easiest way to get this is to just take that Fx column we just made and multiply it by X one more time. I know this column seems a bit random, but trust me, it's a clever shortcut that makes plugging everything into the final variance formula way, way easier.
So once you plug the totals from those columns into the variance formula, you get a number. But there's a problem. The units are weird, something like kilograms squared. What even is that? It's not intuitive at all. That's why we have the standard deviation. You just take the square root of the variance, and bam, you're back to normal units. So for our sugar, we get a standard deviation of 18 kilograms. And that number means something real. It means a typical bag is about 18 kilos away from the average weight. That's a useful number.
Okay, this is where things get really cool. Now that we can measure spread, we can do some powerful stuff with it. Like, how do you compare things that are totally different, apples and oranges, right? How do you compare a score on a really hard test to a score on an easy one? Let's check it out.
Check out this puzzle. A student gets an 82 in chemistry and an 89 in economics. Obviously, 89 is a higher number than 82. But what if the chemistry class was ridiculously hard and everyone failed, while the economics class was super easy? Which grade is actually more impressive? The raw score alone doesn't tell you, does it?
The magic wand for this problem is the z-score. Think of it like a universal translator for data. It takes any score from any test with any average and puts it on the same scale. The only question it answers is this: how many standard deviations away from the average are you? That's it. And it lets you compare anything.
So we run the numbers for that chemistry grade, and we get a z-score of plus 1.75. What does that mean? It means that student scored 1.75 standard deviations better than the average student in that class. That's really, really good.
Now let's look at the economics grade. Remember, the raw score was higher, in 89, but its z-score is only plus 1.50, so it was only 1.5 standard deviations above the class average. Still good, but not as good as the chemistry score. And there you have it. That's the power of the z-score. Even though the raw score was lower, the performance in chemistry was actually better relative to the rest of the class. It just goes to show you, in data analysis, context is absolutely everything. Okay, you know the deal. The only way to really learn this stuff is to do it yourself. So it's your turn. Let's get to some practice problems. Here are a couple for you to chew on. First one is a basic variance calculation on some sample data. The second one is another one of those z-score comparisons. So this is the perfect time to hit pause, maybe grab a cup of coffee and a piece of paper, and see if you can work them out. No pressure, just give it a shot.
So, let's bring this all home. If there's one thing you remember from this, let it be this: an average, by itself, can be a liar. It can hide all sorts of problems. We have a saying, you can't manage what you don't measure. And that is especially true for variability. Understanding the spread is the first step to actually improving any system. Hey, thanks so much for sticking with me through all of that. If this explainer helped clear things up for you, do me a huge favor and hit that like button. Maybe share it with a colleague who could use it. And of course, subscribe so you don't miss out on more of these practical guides. Drop any questions you have in the comments below. I'll see you in the next one.